The way I like to think about is 6 gigahertz is really adding the resiliency factor to the applications, Wi-Fi applications, which is critical for enterprise and industrial IoT.
Access to the 6 gigahertz spectrum for Wi-Fi is creating new opportunities for the factory of the future. We'll learn about smart manufacturing today on The Signal. Hey, this is Martha DeGrasse here again for Wi-Fi Alliance, and this is The Signal, our podcast where we give you the inside track on Wi-Fi. These are meant to be smart conversations with industry leaders. We want to deliver a new perspective on the growing portfolio of Wi-Fi technologies that we see changing the connectivity landscape. And in this episode, we are delighted to welcome Irvind Ghai back to The Signal. Irvind, last time you were here, you were with Onsemi. Now you are VP at Silicon Labs, and we're going to hear from you about how 6 gigahertz, Wi-Fi 6E, and Wi-Fi 7 are empowering enterprise IoT. Welcome back to The Signal.
Thank you, Martha. It's good to be back here with you today. I'm responsible for the Wi-Fi product line at Silicon Labs, and many of your listeners probably associate us with a leadership position in Bluetooth, Zigbee, Z-Wave. And my focus is really how do we take Wi-Fi and then integrating it with artificial intelligence, machine learning, compute, but also multi-protocol wireless support, make value for the IoT space. And that's what we are focused on.
Yeah, I think our listeners are a little bit familiar with SI and Wi-Fi. We had Ross Sabalsik on here a few months ago, and we didn't get that much into AI, though. And of course, everybody wants to talk about that. So I'm glad that we're going to do that today. I'd like to start off, though, talking a little bit about the collaboration between Wi-Fi Alliance and the Connectivity Standards Alliance regarding Matter, because I know you've been very involved in that. Can you give us a little bit of an overview of that?
Yes, definitely. I think one of the reasons, even over the last 3 to 4 years, Wi-Fi has become so ubiquitous everywhere is really the work that Wi-Fi Alliance has been driving. It's not just pulling the different companies in the industry together and working on the next standard. I think the other aspect that should be credited to the WFA is the work they've done on certification. As a user, whenever you go out, you don't even think twice about, is this Wi-Fi device going to work? Is it quality? Because if that certified WFA logo is there, you know that it's a good product. Now, with the CSA and the focus they've done on Matter, it's really complementing that approach as well. Matter obviously is very big in IoT and in some of the cost-sensitive applications. And there's always a concern, is the Wi-Fi aspect of it meeting all the requirements? But with this collaboration that we now have between the WFA and the Connectivity Standards Alliance, as a consumer, I am rest assured that, hey, the Wi-Fi chassis of that product is solid. Just as an example, recently, 9116 from our Silicon Labs portfolio got certification both at the WFA as well as the CSA for Matter, which definitely builds up the confidence as some very low-cost solutions enter the market that it's meeting the requirements of the standard.
Okay, great. That's a good explanation. And just for anyone who's not familiar with the value of Matter and how it facilitates interactivity for different devices from different manufacturers, can you refresh us on that?
Yes, I think the biggest value of Matter is that it's an overlay that's sitting on top of the wireless technology. The best way to think about it is that we have so many choices as consumers on different home platforms and ecosystems from Google, from Samsung, from Apple. Even some of the device makers like TP-Link are in the fray as well. So the value that Matter brings is as an overlay, regardless of the underpinnings of that product, the devices work together. So as a consumer, you don't have to worry about getting one more hub to power on those light bulbs. The whole value proposition is that there's seamless operation between these different devices.
Yeah, it's a very big deal. I think it's going to make people a lot more willing to try the smart home devices,
Finally, yes. Yeah.
All right, let's switch gears a little bit and talk about enterprise IoT. We've heard a lot about 6 gigahertz, so let's talk about how 6E and eventually Wi-Fi 7 are going to play in enterprise IoT.
Yeah, so I think the biggest value is the 6 gigahertz and the additional spectrum that opened up. The way I like to think about is 6 gigahertz is really adding the resiliency factor to the applications, Wi-Fi applications, which is critical for enterprise and industrial IoT. At the end of the day, it really comes down to the application that you're under consideration, because it's always a balance between power, cost, as well as the performance. And that's where Wi-Fi 6E is really shining, because given the fact that it's adding to the resilience of the wireless network, it's kind of accelerated the push from wired to wireless. And that's where the value comes in the factory environment, in the industrial environment, whereas many times you would have had a wired workflow. All that's getting digitized, and wireless with 6E and even 7 down the road are key to enabling that. Now, as a practical example, it's also latency that makes a difference with the introduction of 6 gigahertz and Wi-Fi 6E. A way to think about it is, in an industrial environment, you might have AMRs, autonomous mobile robots, for example, that are being used to transport stuff either in an enterprise warehouse environment or a factory floor. Now, with the latency, if your latency was something like 60 milliseconds, by the time the two-way command between that AMR happens, it might have already traveled a foot. But practically speaking, if we reduce that latency to 10 milliseconds or something of that sort, by the time that command goes both directions, it would only have moved perhaps 3 inches. So that can be very critical in an environment like that. And there's a direct payoff to the value that 6 gigahertz is bringing to that. Now, the thing I always get involved when I'm talking to the customer is all of this is not free. It comes with a price. So for your listeners, as an example, if you had a Wi-Fi 6E module for IoT, it would be priced perhaps something like $20. And a Wi-Fi 6 would be a fraction of that, maybe even 1/4 or something like that. So it really becomes a trade-off between the application. Is it a battery-operated device? Is it lower cost challenged? Versus if you really need that resiliency. And that's kind of the trade-offs, we work with customers on.
Yeah, which is very, very important when they're buying large volumes of these devices. Now, when you're seeing those 3 millisecond latencies or those reductions in latencies, what distance ranges are you talking about between the devices?
Oh, in the case of the AMR example, since it's a moving robot, it would really depend on the workflow. But in many cases, these are going in a circular motion around the factory floor, moving goods from one to the other. But in the example that I talked about, from a latency standpoint, that movement would be something like a foot to even 3 inches of granularity and accuracy.
No, but I mean the distance ranges of transmission, like the round, you know what I'm saying? How far can the devices transmit?
So given the fact that 6 gigahertz, from a propagation standpoint, it would still fit really well, because in this environment, the access points could be loaded with a radius of perhaps 7 meters or 6 meters. So that won't be an issue. That would be part of the topology of the factory floor. Yeah.
Okay, very good. Okay, so some of the IoT devices that you're designing are meant to last for very long periods of time without maintenance, without new batteries. Maybe that's not so true on a factory floor, but I know that you're very involved in some of the low power IoT devices as well. Can you share any metrics related to battery life or some of those other applications where devices are sort of deployed and then they're on their own for a while?
Yes, definitely. But Martha, one point though, you will be surprised even on the factory floor, how much demand there is for battery operated devices. And the reason is going back to our earlier discussion on 6 gigahertz and how the resiliency is helping people go from a wired floor to a wireless floor. In many cases, it doesn't make practical sense, or the cost might be too prohibitive to rewire for these new devices. So we get consumers and users coming to us and saying, well, can we have a battery operated even on the factory floor? And one example would be like cameras that might be used on a battery operated basis to see the flow of traffic on the floor or what the inventory levels are. And it might not make sense to do a wired version of it. Now, to your question, though, the metric that resonates the most with our IoT customer base is what they call low power consumption for standby associated and always on connected states. And to give you an actual number, with our new architecture, the 917, that customers are ramping up with right now, it's really 50 microamp of standby associated current with 1 second listening interval. This is how it gets measured in the IoT space. And that's what the customers compare or look for. Now, what does it mean practically speaking? Like if you had a smart lock, for example, that type of application that many listeners probably can relate to, it means your battery life can last 3 years versus having to swap it every 6 months. And that's the value proposition that we bring by the modification we've done based on Wi-Fi 6. And by the way, that is actually one of the reasons why Wi-Fi 6 is seeing a big transition in the IoT space, because the features, like the WFA also pushed for the target wait time, things of that sort.
Okay, excellent. So are there any other applications that you haven't brought up that are extremely important to your enterprise end users that are supported by Wi-Fi 6?
Yes. I mean, for us, actually, it's a very wide breadth in industrial, in enterprise. We already talked a little bit about factory automation and the switch that's happening between wired and wireless. Another one is predictive maintenance. That is a big one where there's value in combining the sensors as well as the flow of information. The one that is actually taking off in a big way is asset tags and tracking. You actually have startups focused on that space and companies that are growing very fast in that portion of the market itself. Remote monitoring is another one. And then I think we already talked about robotics with the example of the AMRs from autonomous moving robots. All these are spaces and niche applications with their own specific use cases where Wi-Fi 6 finds a home, because the budget from both power, cost, but also the fact that these tend to be congested environments. And with Wi-Fi 6, given the fact that you are supporting OFDMA and the fact you can have dual bandwidth 5 gigahertz support, that helps balance out both the power as well as the congestion.
Okay. All right, great. So you haven't mentioned augmented reality, but we do sometimes hear about that in the factory of the future setting. I think it's used for training as well as troubleshooting. Can Wi-Fi 6 support augmented reality applications?
I think Wi-Fi 6E and most likely Wi-Fi 7 is probably the best application for that.
Okay.
We are starting to see this as emerging applications in both industrial enterprise type IoT environments. And it kind of goes back to, Martha, what we were talking as an example about remote monitoring or remote control of equipment. And the reason I said maybe 6E and 7 are a better choice versus 7 is not necessarily the bandwidth, but more so the latency that Wi-Fi 6E and 7 will bring about, because you'll probably need to be less than 100 milliseconds for it to be effective and realistic. And I think definitely Wi-Fi 6E and a continuation on to Wi-Fi 7 is the right solution in that market.
Okay, great. And when you talk about predictive maintenance and certainly the robotics, I can see how artificial intelligence might be used to maybe process some of the data that the sensors are gathering in a predictive maintenance scenario and maybe to help control the robots. Do you see a lot of edge compute and AI being used in some of the factories that your customers are running?
Yes, that actually has been going on at least for 18 months to 2 years. It's become more fashionable to talk about artificial intelligence now. Right. But practically speaking, there's a lot of value in IoT for both AI, ML models. The way we do it is we actually do hardware assist just to keep the power budgets down and make it more effective from our Wi-Fi solutions perspective. But the use cases are very diverse. AI, if you can understand the data path and predict all that stuff, can also help save power, because you are learning that, hey, the transmission in this direction, for example, and that improves your battery life. The other examples are, what is the inventory level on the shop floor or even in the retail environment? When we talk IoT in retail, we always think about tags, but many applications actually have better battery-powered cameras that are just keeping track of entry level from an application perspective. And what that means is, from a partitioning standpoint, you don't need to deal with the cloud for all that work. At the edge in IoT devices, even with the limited memory or the limited compute, you can do functionality like count, you can do functionality like direction of traffic, which the value that brings to our market base or our customer base is it takes away from the need to process that stuff in an external MCU and then interface that with the cloud. So that's where the expense is. So if that stuff can be done at the edge, and only the stuff that decides then goes to the cloud, it provides a nice system partitioning, and it saves a lot of cost as well as it saves latency. The decision can be made with the IoT device itself.
So some processing is being done on device, obviously some in the cloud, and some sort of in between at edge compute servers. Is that what you're describing?
Yes. So the way to look at it would be the first pass analysis and decision, if you want to use that word, could be done at the edge with the IoT device.
Uh-huh.
So the information then you are passing on to the more sophisticated AI systems has already taken that into account, and that would be a more dedicated application with a more powerful MCU, most likely, that would then work with the cloud aspect of it. But if you can parse away 60% of unnecessary traffic having to go between the cloud and that more powerful artificial intelligence device, you're saving time and cost.
Absolutely. Okay. Now, I'm sure you know better than I that a lot of the things you're describing are also promoted as capabilities of private 5G networks in factory settings. So how do you differentiate? Obviously, I'm guessing the cost is probably less with a Wi-Fi system, but there probably are some other differentiators as well, right?
Yes, 5G will be associated, for example, with royalties and things of that sort. If you just take a look at the diversity of suppliers, we have so many choices on Wi-Fi. It's a very nicely developed ecosystem. We talked about the WFA's role in making that happen. I think all that creates more support, more applications, which perhaps cellular would not be able to do. But the way I take a look at it is it's not a one or other or a compete situation. It's more like a toolbox. Just like we use the example when you asked me about AR, is it Wi-Fi 6 or Wi-Fi 6E or Wi-Fi 7? I think 5G is another tool in that toolbox where it might make sense. But in most examples that I see, they tend to coexist. So you could have a big factory floor that could have cellular as a portion of the backbone, but that doesn't distract or take away from the fact that many of those cost-sensitive, power budget-sensitive applications could be not only handled, but handled properly by Wi-Fi 6. And that's how we service that market.
Are there some applications that need to straddle both and make the networks need to interact with one another, or not really?
I think not really. I mean, like a couple of years ago, there was a lot of push on how we could have 6 gigahertz be part of a private network, and there were talks about sharing the spectrum and things of that sort. But in most cases, maybe it's just a practical rollout of the technology. From a provider standpoint, 5G or cellular is typically handled and rolled out at a different time from a Wi-Fi perspective. And it kind of goes back to how diverse the Wi-Fi ecosystem is, how many niche applications it's supporting. So I don't think the buying and the deploying cycles are the same. So by definition, they don't have to be hand in hand.
Okay, that's super interesting. All right, Irvind, is there anything else that you want to cover while we're here? This has been really informative.
No, thank you again. It's always good talking to you. And I think we did talk earlier that we will be doing a lot more in depth, both on Wi-Fi as well as AI, ML, and multi-protocol at our WorksWith event online. It's a virtual event, and we'll make that information available to your audience as well.
Okay, good. Yeah, we'll get that into the show notes. Thanks for bringing that up. Okay, that is our show. And be sure to follow us on Apple Podcasts, Spotify, Google Podcasts, and Amazon Music to get all of our latest episodes straight to your device. For all things Wi-Fi, check out y-fi.org. That's the Wi-Fi Alliance. I'm Martha DeGrasse. Thanks so much for listening, and please join us next time on The Signal.